Hello and welcome to today's video. In today's video we're going to be working on a mechanic from a new game that's just come out called Don't Scream, where the game detects your microphone input and if you scream or shout, the game is over. So in the mechanic here we can see that if I speak loud like this and our volume goes above this bar here, a scream has been detected. If we whisper really quietly, it doesn't get detected. And it's when we shout it gets detected. So full disclosure, the kind of basis of this tutorial is based on this one here. This was a 13-minute video from a guy who mainly does VR tutorials, and I use this just to figure out within Unity how you actually detect someone's microphone and also determine the loudness of it. This kind of ends just being able to get like a loudness volume from it, and it goes into showing you how in VR you could like use it to control a mouth movement. It's a really good video. Really concise, and then obviously I've took this and then adapted it further to get our little project here where we can choose a different microphone source, we can calibrate it, we've got the slider and the detection, so obviously all of that's custom, but I just thought, you know, it'd be nice to acknowledge that some of the initial code, even though I've tweaked it, came from this video, which I will link in the description below. And for those of you who don't know, Don't Scream is a game where if you scream, you restart. So if you scream, you restart. An Unreal Engine 5 short horror experience made by 2 indie devs. The challenge, explore the forest for 18 minutes without screaming. The catch, time only ticks when you move. It's the perfect game to scare the pants off your friends and family, and a microphone is required. So this came out to great success. One of the developers on Twitter has been talking about how much money it's made and how many wish lists it got, and apparently it's done really well for them. Reviews have fallen to mixed now, and it's had some really good YouTuber pickup and support, probably the biggest of which was Markiplier did a video on it as well. So that's what Don't Scream is. With that said, let's get straight into programming the actual mechanics we're going to see here. So I've just opened a new project in Unity. This is just a 2D project using the built-in render pipeline. I just picked 2D core, and we're using editor version 2022.3.11 F1. Okay, so the first thing is we need to be able to detect audio, obviously from the microphone. So the way we're going to do that is we're going to make a new game object, and we're going to call this the audio loudness detector. And to this, we're going to add a component with the same name. So audio loudness detector. And we will open this up here. So in this script, we're going to have one main method and then a couple of other bits and pieces in it. But the main method is going to be a public float. And it's going to be called get loudness from audio clip. And this is going to take in an integer called clip position, as well as an audio clip. And we can just call that clip. So the first thing we need to do is we need to create a start position, and we can do that by doing int start position, and this is equal to our clip position minus the sample window. And we're actually going to make the sample window up here, so we'll do public int sample window, and we'll set this just equal to 64. So what sample window is if we have a clip position, say 30 seconds into a clip, we need to take a sample of data from before that clip position, then we can add all of the loudness in that sample window together, and then we can get a mean sort of clip loudness, and then we'll work forward to our original clip position. Then next, we want to check whether our start position is now less than 0, because if it is, there'll be an error because we'll be prior to the clip having started and there'll be nothing to sample from. So here we can just return 0, and the loudness will be 0 because there's no data to actually sample from. So now we can make a float array, and we can call this wave data, and we can set it equal to a new float array, and it'll have a size of sample window. So we're going to get 64 in this case floats in an array, and then we can fill each of those floats with a sample of data from the waveform. And the way we do that is we go into our audio clip, and we can use the get data function, which is a built-in, And you can see here it just says fills an array with sample data from the clip. What we need to do here is this takes in our new array which we've just made. So we can do wave data, and then we have to pass in a offset samples, and we can just use our start position for that. So this is going to go from our start position and it'll work forward to our clip position, and it'll fill this wave data float array with data from the clip. Then to this we can do float total loudness equals 0, and then we want to do for each variable sample in wave data, we can say total loudness is plus equal to mathf.abs sample. So looking at a waveform, you can see that you've got the central line, which in this case will be 0, and then anything above the line will go up to 1, and anything below the line will go to -1. And -1 doesn't mean like negative quietness. Obviously that's not a thing, it's just part of the waveform data with the peaks and troughs. So we just need to get the absolute value here. So if we are at -1, we'll actually add 1 to our total loudness. And then we can just return total loudness divided by our sample window, and this will give us the mean loudness as a float. So to check this is working, what we want to do is we want to go back into Unity, and now we can just create a 2D object, and I'll use a sprite, and we can just use a circle for this. I'll rename this to scale with loudness. And to this, I'm going to add a script called scale from audio clip. So what we want to do here is, depending on how loud the audio clip is and how loud we're speaking or shouting, we're going to lerp between a minimum scale and a maximum scale. So to do that, we need to get an audio source, and this will be our source, and that's so we can pass in the clip to the get loudness from audio clip function that we've just made on our loudness detector. We want a public vector 3, and we're going to do min scale, and we can do max scale. And we need a public audio loudness detector, and we can just call that detector. So that's a reference to this script here. And then in update, we can say float loudness is equal to detector.get loudness from audio clip, and then we're going to put in source.time samples as our first parameter, which is clip position. If we look at what time samples is, we can say it's the playback position in PCM samples here. And it also needs the actual clip from our source as well, so we can do source.clip. Now with that we can lerp between the minimum scale and the maximum scale based on this loudness. So we can do transform.local scale equals vector3 lerp. We do min scale, max scale, and loudness. And we should be able to see that working. So if we go into our project here, we need to add an audio source to this game object. So we can drag that into audio source. For our min scale, we could do 111. For our max scale, we could do 555. We need to drag in the audio loudness detector. And now for audio source here, we need a clip. So you can use any clip here that you want. I've just used some finger snapping that I recorded in Adobe Audition. I'll provide a link to this if you want to use this exact clip. You'll be able to find it for free on my Patreon. So I'll just import that now. So this clip is just me clicking my fingers. Like various volumes. So to scale with loudness, we can drag in our finger snapping clip. And that should work. If we hit play, based on the waveform of our finger snapping, this will scale up and down according to how loud we are snapping. You can see that happening here. If we click loop on our audio source just so it keeps going round, but you can see it's not going to the full 5x5, and that's because loudness gets presented quite as a quite small number. This loudness, it doesn't ever really go near 1, which is what, if it was 1, we'd be at max scale. At 0, we're at min scale. Anywhere in between that, you know, that's what a lerp is. So we can multiply this by sort of a sensitivity to make it a bigger number, basically boosting the loudness artificially just for the purposes of the lerp. So we can make a public float loudness sensibility variable, and we'll set that as 100f. And then we can also make a threshold, so public float threshold. I'm going to set that equal to 0.1f. Now, to sort of demonstrate this, I'm going to do debug.log, and we'll print out our loudness value. We'll say if loudness is less than our threshold, we'll set it to 0, so it's not being detected and jumping around even at small sort of thresholds. You don't need this bit, it's just a nice kind of little buffer, so it's not picking up like weird stuff in the background. And then we can actually just times this by our loudness sensibility. So we can see that working there. That was scaling up and down quite nicely. If I set this to loop, actually we'll have to come out and play, set that to loop, and we can play with these values so you can see them working more. So if we set our threshold to 0.5, it's not actually going to scale unless this number down here goes above 0.5, and that's based on how loud it is, obviously. And we can change the sort of sensibility to scale this number. So if we just had that at 1, you can see it's 0.00. There's a lot of trailing or preceding zeros. So we can just set that to 100 just to kind of give it a nice boost. And we can see that going from 1 to 5 up here now when it's actually scaling. Okay, so next we want to be able to actually take in our microphone audio and have it scaling based on our microphone, not based on this finger snapping sound. So what I'm going to do is I'm going to just move this over to the left and then duplicate it. I'll move that one over to the right. And I'll rename this actually to scale with clip, and I'll rename this one to scale with microphone. And we'll change it to a square, just so we can see the bit of a difference in them. And I'm going to get rid of these two scripts. We don't need these. Now to this one, so scale with microphone, I'm going to create a new script called scale from microphone. And we'll open this up. And I'm going to copy from our scale from audio clip method. I'm going to get the interior of this, and let's just copy it and paste it over into scale from microphone. So this, we don't need a audio source, so the rest can be the same. So instead of get loudness from audio clip, we're going to go over to our audio loudness detector file, and we're going to add a bit more functionality to this, which we can then go back to scale from microphone to implement. So let's make a new variable here, and we'll call this public audio. This can be a private audio clip, and we can call this microphone clip. And then we can make a private void function, and we can call this microphone to audio clip, and this is going to take in an integer which we'll use a little bit later on, but we'll put it in now, called microphone index. So the way microphones are stored in Unity is we've got a microphone class, and this has an array of devices, which is just an array of strings, and that's their names. So what we can do here is do for each, and let's say name in microphone.devices debug.log name. And if we just go over here, let's actually comment out this function so we can actually get it to compile, because I need to show you what I mean by these devices. So private start, let's just call microphone to audio clip, and we'll pass in 0 for now as an index. So if I go over to Unity, and I'm actually going to just disable scale with clip for now. If I hit play, you can see here in our console, we've got microphone Yeti Classic, which is the microphone that I'm recording on. We've got microphone Logitech StreamCam, which is my plugged in USB webcam. And then we've got Steam streaming microphone as well. So these are the microphone devices that I've got installed within Windows. What you want to do is make a note of which microphone, for now, just in this debug period, while we're setting everything up, make sure that, so if you're using your webcam microphone, but it's showing as like the third one in. So if I wanted to use Steam streaming microphone as the microphone for this test of when we try to get this working, that'll be index 2. So we'll have 0, 1, and 2 as our device IDs in the array. And what I mean by that is if we type it in here, so string microphone name is equal to microphone.devices, and this has to this is an array and we need to give it an index. So if I want it to use my Yeti microphone, I'll have to put in 0. If I want it to use my webcam, I'd have to put in 1. And if I want it to use the Steam streaming microphone to detect me speaking, I'd have to put in 2. So for me, my Yeti microphone is the one I want to use. I know from this that it's the first one in the array, which is index 0. So for the purposes of setting this up, before we have this nice drop down, because remember we're going to eventually have a drop down here where we can pick which microphone we're actually using from them all that are selected. Here I'm going to put microphone index, that'll be the one that we're choosing from our devices, and I'm hard coding 0 into our I'm hard coding 0 into our start function because that's the one I want to be the default. I want it to be my Yeti microphone. If the microphone that you want to use, again, if the microphone that you want to use is in a different position, then add that into that start function. So if you wanted to use this one, that's the second one in the list, put 1 here. But for me, I want to use the first one, which is my Yeti, so I'm going to put 0. Now we've got our microphone name based on this index. We are going to make a new clip and assign it to this microphone clip variable. So we'll do microphone clip is equal to microphone.start, and this takes in the device name, so it doesn't take in an index. That's why we've had to get the name here. So we can start our microphone name, which for me again is the Blue Yeti. Then it takes in whether it should loop and carry on looping your microphone. So we want that to be true. So we want it to always be listening out for our microphone. We can set a length in seconds. You want a high number here, so we'll do 20. This doesn't really matter because it's looping. It'll just be like a rolling record, but we just want 20 to give it enough of a buffer so we can actually sample it and take loudness from it. And then frequency is another integer, and this is set in our audio settings in project settings. So we can just do audio settings dot output sample rate. So again, that's set within Unity. You don't have to know what it is, just put audio settings dot output sample rate. And I'm going to get rid of this for each loop because we don't actually need it. That was just for demonstration purposes. So now I can make a public float function called get loudness from microphone. Loudness from microphone. So here we just want to return our get loudness from audio clip function, and we need to pass in a clip position. So we can get this from our microphone. So we can do microphone.getPosition, and this takes in a device name, and we've got our device name here. What we want to do is we actually want to change this and store this outside of the function. So we can come up here and do private string microphone name. If we get rid of string here, so now we're setting microphone name. And good coding practices, we should have a underscore before microphone name. Right, so here we can pass in our microphone name. And then the actual clip is our microphone clip. So here we're turning our microphone into an audio clip that's going to be rolling record based on what we're saying to it and how loud we're talking. We can then pass our microphone and the clip into the function that we made earlier, which gets a loudness. And now we are returning that in this new function called get loudness from microphone. So if we go back to our scale from microphone class and then we uncomment this out, here we don't need any of this. We can just say get loudness from microphone and then times that by our loudness sensibility. If we go back into Unity, we've got our game object here, scale with microphone. We need to set this back up, so we could do 111 555, drag in our detector. So now when we start speaking, when we hit play, the cube will go bigger based on how loud we're talking. If we whisper, it'll be smaller. I've got a lot of background noise that the microphone picks up, so I can change the sensibility or the threshold if I want. So if I want to cut out some of the background noise, we can just drag up the threshold to like 1.27, and if I don't say anything, see, it's not actually getting picked up. So my kind of like background noise doesn't go above like 0.2, but when I speak it does go above this threshold, and we can see that here based on my voice. Okay, so this is kind of where that original video that I mentioned ended, or at least where I jumped off. That was kind of as far as I needed. If I didn't explain any of that properly, I'd go and recommend just watching that video, just so you can kind of understand. He explains it a little bit better probably than I did, but from this point on, this is all me, baby. This is stuff to actually work on getting the don't scream functionality working. So we can actually just hide this scale microphone now we know that it's working. And we're going to make a new UI canvas. So we'll go UI canvas, and we can set this to scale with screen size. Just to get rid of this checkbox, this like warning, I'm just going to click vertex color always in gamma. For the reference resolution, I'm going to do 1080p, and we can to this. We're going to add a image, and it's going to be a fill bar. So we'll do Unity UI. So we will right click UI image, and we want to set our image. Well, it needs a sprite first, so we'll pick UI sprite. I'm going to set it to filled, and I want it to go horizontally and fill from the left, so we can set this here. Now the built-in UI sprite, it's a bit rubbish. They're very blurry, and if we go to look at our UI, it stretches weirdly. So in the same folder that we had the finger snapping at the same link in the description, I have included a plain square here, which has just been set up to, you know, it scales nicely. It's not like blurry or anything. So we can make this as big or as little as we want. And now the fill amount, if we're at 0, it's gone. If we're at 1, it's full. And now you can, as you'll expect, that loudness variable, instead of lerping between a scale of like 1 to 5, we're going to use it to set our slider. So as we talk, it will go up and down like this. And when we shout, it'll go to the top. And when we speak quietly, it'll hopefully stay down here. And we'll see it doing this. So let's set this up. So what I'm going to do is I'm going to go into our rect transform. I'll hold Shift and Alt, and we'll click the middle one just to set it to the middle of our screen. We'll set it to 1 so we can see it. And then I'm just going to hold Alt and drag on the right hand side just to fill it, just to set the fill, kind of to fill up more of our screen. So we can see it as we talk. It'll be doing this now, and we'll be able to see the actual loudness a bit better on like a bigger scale. And I'll just move this down here. And so with this, I'm going to right click, create empty parent, and I'll do audio loudness meter. And then I'm going to duplicate our image here and set it as a child of this top one. And we'll call this threshold indicator. And I'm going to hold Alt, drag this in, just make it a little bit bigger, and change the color to like red. So now as we set this, the idea is that once we go past this threshold, that is when a scream has been detected, and we'll get the kind of conditions being met that a scream has been detected. And to this top level object, audio loudness meter, we're going to add a new script called fill from microphone. So now again, from our scale from microphone clip, we're going to copy and paste this. And you'll notice that we're copy and pasting a lot. A better way to do this is, so instead of inheriting from mono behavior, we could maybe make a new class with some of this shared information. So like the detector and stuff, put this into its own function and make it a virtual function so we can override it. But that's kind of out of the scope of this video for now. We'll just do the old copy and paste, because we'll only be really using this script from now on anyway. They were just like test scripts to just get it working. And we'll paste that in here. But we need to make some changes to obviously make it work with our fill bar. So we don't actually need the minimum scale and maximum scale, and we're not going to be doing this lerp for the scale here. So we can get rid of those there. What we will need is a public image using Unity Engine's UI, so using Unity Engine.ui, and we can put this as our audio bar, we'll call it that. So with that image audio bar, we can then come down here and we do audio bar dot fill amount is equal to loudness. We'll go back into Unity, we'll assign our loudness detector, we'll assign our image here with the fill amount, and we'll hit play. And hopefully, as we speak, we'll see that that audio bar goes up and down. If we're quiet, it's right at the bottom, but when we speak, it goes above our threshold here, and obviously I'm speaking quite loud here. So that is working. We can hit play. And I'm going to get rid of this debug.log actually, because it's a little bit annoying. So we'll get rid of that debug.log. And instead of setting loudness to 0, which means that the bar completely disappears, I'm going to set it to 0.1f. So it'll always have a little bit of fill in it, just so the player can see that there is a bar there. I think it just looks a little bit nicer. So next, we want to add a slider, which we can use to calibrate the actual microphone, because we're just hard coding a sensibility here. Every player's microphone is going to sound different and pick up different noises. have more like static built into it, for example. So we can give the player a little bit of control over their microphone calibration, sort of based on their surroundings. So with our audio loudness meter here, I'm going to right click, create UI, and we can choose slider. And now the slider is really small, so what we need to do is we just need to reposition this, and we can make it bigger. What I'll do is I'll set it like sort of this size and then move it over so we can have some text here. And I want to change this handle, and we can pick our plain square here. So now we have this slider which we can move up and down. It doesn't obviously do anything just yet. And while we're at it, let's just add a bit of text. So we're going to do text mesh pro. We'll import TMP essentials. We'll just drag this up here, and we can say this is the microphone calibration. And I will set that just to be capitals, just in case we want to type anything else in there. And for my demo project here, I was using this VCR kind of font, which I got from Dafont. I will include a link to it in the description below. I'll import that into this project now. Once you've got whichever font you want imported, we can right click, create Text Mesh Pro font asset, and then on our text here we can just drag in our VCR font, and that just makes it look a bit nicer. I'm going to change it to auto size and set the alignment to sort of align with the middle of the box. So this slider currently doesn't do anything, so we need to make a function that we can use to get the value of our slider and then do something with that. So let's go back over to our script, the fill from microphone script, and I'm going to make a public void set loudness sensibility, and this will take in a float which we can just call T. Now, instead of this loudness sensibility here, I'm going to rename this to current loudness sensibility. And then make two more floats. We'll do public float minimum sensibility. We'll set that to 100, and then we'll have public float maximum sensibility, and we can set that to 1000. And then here in our public set loudness sensibility method, we can say current loudness sensibility is equal to mathf.lerp between minimum and maximum sensibility with a value of T. So if the slider's all the way at right, we'll get a value of 1. So that'll be our maximum sensibility. If it's in the middle, we'll get 0.5, which will be in between minimum and maximum sensibility. And if we get 0, that'll just be our minimum sensibility here. We might want to make it so we can go even lower than 100. Maybe for some people 100 won't be low enough, but then we can change this in the inspector anyway. And for current loudness, I'm actually going to set that to 500. And then we want to get a reference to our slider. So we'll do public slider sensitivity slider. And I'm going to make a start function, and we'll do we'll say if the sensitivity slider is equal to null, then let's just return, because we're about to try to change some bits on it. And we'll do sensitivity.slider.value equal to 0.5f, and then we'll use set loudness sensibility to sensitivity slider.value. So we're setting this kind of halfway, and then we're actually setting the sensibility to the value, so it matches kind of directly from the start. We'll go back into Unity, come up to our audio loudness meter, and we'll drag our slider into the sensitivity slider here. And I'm just going to rename this to calibration title. Okay, so we can see our current loudness sensibility here. When we hit play, we're going to set it to 0.5, which is 550. So that's 550 is halfway between 100 and 1000. And you see that's quite high for our sensitivity. So if we want to calibrate our microphone, we can actually make this lower. And as we drag this down, you can see nothing happens, because of course it doesn't, because we forgot to, in our slider, where it says on value changed, we need to drag our audio loudness meter into this and then choose the function that we've just made. So now when we click play, and we go back to our audio loudness meter, as we change this, we can see the value here of current loudness sensibility changing. So if we drag this all the way down, this calibrates it so it's really quiet now. So you can see this isn't, when I don't talk, this is the kind of the background sound. I can basically boost that, so I go all the way to the top. It's always full because my background sound is now multiplied by 1000. So a player will want to calibrate their microphone, so if they whisper, it doesn't go above it. Obviously I'm having to whisper loud so you guys can hear me. But if I shout, it goes above the red, and if I'm quiet, it doesn't always go above the red. So we might actually want to make minimum sensibility something like 0.1, for example, and then if we drag that down, see now I'm speaking quite loud, and it's not really going above it. So this gives a lot more finer control to the player to actually calibrate their microphone. Okay, so we're nearly done. On my main camera, I'm just going to go to background, and we'll change it to that kind of nice VCR blue that we saw in the test project. And I'm just going to move this stuff up just slightly. So now we're going to make a drop-down list so we can actually choose the microphone in case the player's microphone isn't... we don't want to hard code 0 because the first microphone in that list might not be the microphone that the player wants to use. So that is quite easy to do. What we want to do is create a drop-down. So what we can do is right-click our canvas, go to UI, and we'll do drop-down Text Mesh Pro. And we see that comes in here, and it's quite small, so let's sort of scale this up. We go into drop down, we'll go on to our rect tool here, and we can just drag this out to kind of fill this space, and we'll make it a bit bigger. For the label, we can click auto size, make it always capitals, and we'll choose our VCR font. And we might want to just give it a bit of kind of breathing room here. You might also want to make the arrow a bit bigger to match kind of the scale of the UI. And in our template, we'll have to just expand this so we can actually see the drop-down list here. So this is what it'll look like when we have some options. You can see this is quite small, so we'll want to go to template, viewport, content, item, and then we can make the check mark a bit bigger. Go to our label, just drag that in a bit, and then again, we want to set our VCR font, choose auto size, make it always capitals, then we can make this option just a bit bigger so we can actually see that easier in the drop-down list. And then we can hide template, make sure you re-hide that drop-down. I'm going to rename this to microphone selector, and let's add a script to this, and we can call this microphone selector and open that up in your IDE. So we'll zoom in here. I'm going to get rid of, I'll get rid of the update function. I'm going to get rid of this comment as well. So we're going to make, going to get a reference to the dropdown that we just made. So we can do TMP dropdown, and we'll call this the microphone source, or just source dropdown. And we want to keep track of the chosen device index, and I'll set that to 0 by default. And in start, we'll make a function called populate source dropdown, and that'll just be a private void method. So you can see here that back in Unity, on our dropdown, we've got this here options, option A, option B, option C. So when we call, so basically this method of populate source dropdown is going to actually fill it with correct text, so it doesn't say option A, option B, for example. So what we need to do here is we can just make a generic variable called options, and we will set this equal to a new list, and it's going to be a type of something called option data. But you can see there's a few here. There's unityengine.ui.dropdown and tmpro.tmp.dropdown. Option data, we want to be the TMP variety, so we'll select that, and the way that looks up here is we have to be using TMP Pro, which we are anyway because of this source dropdown. And then just make sure you do TMP dropdown dot option data here to make sure it's using the correct version of option data. Then we're going to do a for each loop, so we say for each variable microphone in microphone.devices. We're going to make a new piece of option data and then add it to this list. So we have to say tmp underscore dropdown dot option data. We can just call that option data is equal to new tmp dropdown dot option data, and we can pass in into the constructor our microphone name, and it wants a sprite, which we're just going to say null because we don't have a sprite to give it. Then once we've got our option data, we can do options.add option data. So we're going to make a new piece of option data, which is going to just have a string, which is our microphone name, and then we're going to add it to this. Then we're going to add it to this options list here, and then we need to get our source dropdown, which is this here. We're going to do source dropdown dot options, and we'll set that list equal to the list of options that we've just made. So that will now populate the dropdown list with the correct data. And then we can make another method called public void choose microphone, which will take in an option index. And we can say chosen device index is equal to our option index. So let's go back over to Unity. That's the wrong one. Go over to Unity. In onValueChange, we'll hit plus, and we want to drag in our microphone selector and choose the choose microphone method. So when we hit play, we'll see our options change to our microphone names. No, we won't, because we have forgot to drag drop down into our microphone selection script. So we'll hit play, and now we should see them change. So we see options here, microphone Yeti Classic, which is the string, and then we passed in null for a sprite, so there is no sprite. And when we choose one of the different microphones here, we can see that working, and our chosen device index changes based on our device name. There's a bit of overlap here in our drop-down list that doesn't look quite right. So back to template, let's just enable that again, And if we just give a bit more room to content, I believe that should fix the issue. It did not. So maybe we need to just make the label a bit smaller. So we'll hold Alt and just resize that slightly and maybe move it up. Does that give it a bit more room? There we go. So that's got a bit more room there. So we can, there's no overlap. So we've got our, we can now choose which microphone we're actually going to use for this loudness, or at least we can pick the name of it. We actually need to plug that into the detector. So what we can do for that is, back in our microphone selection script, we want to make a new static Unity action. So we'll say public static Unity action, which will give an int parameter, which is going to be our chosen device index, and we can call this on microphone choice changed. And then when we actually choose a new microphone, we can invoke this event. So we do on microphone choice changed, question mark, invoke chosen device index. Now over in our audio loudness detector, so this is where we're actually picking which microphone to use for our audio clips. We can make an onEnable function, so private void onEnable, and we're going to listen for that event that we've just made. So we'll do microphone source microphone selector dot on microphone choice changed, and we'll assign a new method that we're going to make called microphone change microphone source. And then in onDisable, we'll have to make sure we unsubscribe from that as well to not throw up any errors. It's always best to unsubscribe from these events as well. And we can make this new method, and it's going to be a private void change microphone source, which will take in an integer, which we can just call device index. And then here we can call microphone to audio clip again, but instead of hard coding 0, we will pass in our device index, which will call this method, and it will overwrite the clip with a new clip based on our new microphone, and it will, select that properly based on our index. So let's take our calibration title, duplicate it, we'll drag it under microphone selector, and we'll move it up. And we'll say microphone source. And I actually want this the size of this to match microphone calibration. So calibration title is currently at 37.8. So if we set this max to 36 and then calibration title to 36, they should match. We could just rename this to microphone source. So I'm going to take both of those and just shift everything up slightly. Right, so let's hit play and we can see if this is all working. So here I'm using my Yeti Classic. If I pick Steam streaming microphone, I'm not currently using that microphone. It's like a virtual device based on Steam. I think it's there from when I had a VR headset, but if we choose this, it won't work. It's not getting any loudness, it's not picking up anything, so we're at 0. We can choose our Logitech StreamCam, which is the webcam. That's really loud all the time, so we can just drag the kind of calibration down. See if I'm quiet, it is picking it up, but it's being a bit weird. So we might actually want to go even smaller on the calibration with that. But my Yeti Classic is the good one. So that is how a user can now choose which microphone they want to use. Again, for our see the minimum sensibility reset, 'cause I must have changed it in play mode. So if I put that back to 0.1 and hit play and select my StreamCam and drag this down, See, I've now calibrated that where if I'm quiet, there's not much input registered, but as soon as I start speaking, it goes back over. And that's going to be different to my Yeti Classic, which will need a different sort of calibration. So that is how that works. So just make sure minimum sensibility, drop that down to something lower, give it a bigger range for people to calibrate their microphones differently, because each one will be different, and that's the whole point of the calibration. So now we just need some sort of thing, something to say that a scream has been detected. So we're going to come out of play, and I'm just going to make a new bit of text. So UI Text Mesh Pro. I'm going to hold down Shift and Alt, and we'll choose the bottom under the anchor. Then we can move that up slightly. I'll type in scream detected. Choose our VCR font. I'm going to make it red. Center it. I'm going to choose auto size, and we'll just scale the box up. And give that a max of 100. So let's just bump everything up slightly. We'll move the text down. Rename this to scream detected text. So now this is obviously just for UI purposes, but once we've done this, from that point on, you can just then implement this into your game to trigger anything if the person screams or speaks too loud. So let's go back over to our script. We'll go to our fill from microphone script. And here, I'm just going to make a new public game object reference called scream text. And in update, when we fill our fill amount bar, we can say if loudness is greater than 0.5F, so we'll know that the bar is at least half full, which is where we've put our red line. So if loudness is greater than 0.5F and the scream text is not active in hierarchy, so active in hierarchy. So if it's not active and we've shouted, we need to switch on that text. So we can do scream text dot set active to true. And then conversely, if loudness is less than or equal to 0.5F and the scream text is active in hierarchy, then we want to turn it off. So set active false. And in our audio loudness meter, don't forget to select our scream option, scream text, hit play. Now when it goes above the red bar, the word scream detected come on. If we turn this down and if I stay quiet and we're below the red bar, it won't show scream detected. But as soon as I shout, a scream has been detected, so the game should be over based on the rules of the game. Don't scream. So from that point on, this is completely up to you how you want to handle this. If you're actually making a game with this mechanic, what you could do is make an event, so public static Unity action on scream detected, and here we can just say if loudness goes above 0.5F, then we'll say on scream detected. If anything is subscribed to it, which is what the question mark means, we can just invoke that. And then you can obviously, in your game manager, listen out for this event and then end the game if the player screams. So there we have it. That is everything. Obviously, in this project here, I added in a bit of post-processing and just make it look a little bit nicer. But yeah, that's kind of out of the scope of this tutorial, the post-processing. But this is our final kind of look here. We've got our microphone that we can choose between. And we've got our different microphones, and if we speak above this threshold, a scream has been detected. Now you could obviously move this a bit higher and, you know, change the threshold of a scream from 0.5 to 0.75 or whatever. But this kind of middle ground is a nice place to kind of calibrate to. And we can drag this down so as I speak, it doesn't actually detect a scream. So I can speak quite nicely here like this, and if a scream hasn't been detected, we can calibrate it so as I speak, a scream gets detected. Hopefully you liked this tutorial. If you did, it'd be great if you could let me know by giving the tutorial video a thumbs up. Subscribe for more content like this in the future. And if you want the project files for this video, they will be over on my Patreon, which is patreon.com/danposs. But in the meantime, thanks for watching, and I will catch you guys in the next one. Bye!